All right, so sorry about that. We went into the t-test, right? We learned all the stuff about the t-test. So remember, the t-test is just going to compare values, two average values, excuse me, from a sample. And then basically what it does is it says, okay, do those average values from the sample, can we say that's representative of the population? That's what it does. And so in this problem, we took engineering students and literature students, 15 from each, and we calculated their averages. Those are the averages for the sample, this set right here. Okay. Now, what we want to do is, can we say the engineers look like they're smarter, 112 versus 104, but can we say that they're smarter as a whole? And that's what the t-test does. It compares the sample, which is 15, to the population, which is like the whole earth, right? Well, I shouldn't say the whole earth, but roughly speaking, you can always abstract the population to the whole earth. So basically, your t-test is going to tell you if your actual average difference is significant on a large scale. Okay, can we definitively say that the engineers are smarter as a whole? And so the t-test pops out a p-value. Okay, and in this case, we got 0.057, which is just a bit bigger than 5%. If your p-test gives you something bigger than 5%, or your p-value is bigger than 5%, you can't say that it's significant. Okay. So you can, in our problem, we couldn't say that engineers have a higher IQ in general. If your p-test is smaller than 0.05, or smaller than 5%, then we can say that there's a significance in that, yes, in general, engineers tend to have a higher IQ. There's actually a difference there in the real world. Okay. Then we talked about the one-sided versus two-sided. The two-sided t-test gives you p-values that test to see if there's any difference between the values, where the one-sided t-test gives you a more detailed comparison. It basically wants to figure out if one value is greater than the other. Okay, so the one test, the two tests basically say, are they different, whereas the one test is going to say, is one or the other specifically greater or smaller. Now I want to talk about the z-test. Okay, so we got the z-test. That's a little bit ugly. Z-test. The z-test is basically like a more detailed version of p-test, or of the t-test. Okay, so I'll say more detailed. Jesus, let me write that. I got to get a better feel of my handwriting. More detailed than t-test. Okay, and so there are some specific criteria for when you use the z-test versus p-test. So you got z-test versus p-test. Okay, and so the whole idea is the t-test is going to compare averages, compare sample average. The z-test does the same exact thing. It compares sample average. Okay, it's like the t-test but specific. I'm gonna put samp average. All right. Now here's the difference. The t-test, you don't know anything about the population. Don't know about population. Remember, the population is the greater size. Now, you have the sample information, but you don't have the population. The z-test, somehow, you only know the standard deviation of the population, which is hilarious when you really think about it, because if you knew the standard deviation of the population, you probably know the average of the population. Okay, so you know the standard deviation of the population, but you don't know, and I'll put that in red, you don't know the average. Because if you knew the average, then you could just do a more accurate, a different test. Don't know the average. Okay, so that's one stipulation. You don't know the average, but you do know the standard deviation of the population. Okay, keep in mind that I'm saying specifically population. Okay, it's one criteria for picking the z-test. The second criteria for picking the z-test over the t-test is that your sample is smaller than 15. Sample is small. And I'm saying smaller than about 15 to 30. And so I'll say about 15 to 30. The sample is smaller than that. Okay. And so a lot of people just say 15. But the whole idea is if your sample size is smaller than 15 to 30. So in our problem before, we had 15 students. Technically, with the engineers and the literature students, technically we have 15 engineers and 15 lit students. That's 30, right? So that is small considered. But the thing is, we don't know the standard deviation of the population. Like, we didn't know this, and so we couldn't use the z-test, excuse me. If we happen to know the standard deviation of the population, not the sample, All right, I can find the standard deviation of my sample of 15 kids. I'm talking about engineers versus lit students on a greater scale. If we happen to know the standard deviation of that, like as a population, I would have been more likely to use my t-test, my z-test. I always get those confused, excuse me. Okay, but because I didn't know that, I'm still stuck with the t-test. Okay, so whenever the sample is smaller than 15 to 30, and you know the so whenever you have this case and you know the standard deviation of the population, you can use the z-test over the t-test. And the funny thing about it is, once the standard deviation, once the sample size becomes big, the t-test and the z-test basically do the exact same job. They literally give you pretty much the same answer. All right, the difference between them starts to shrink as the size of your sample gets bigger. Okay, and so the whole idea, honestly, is that when you're doing z-test versus t-test, z-test is great for tiny samples when you know the standard deviation, and it gives you great accuracy, like huge accuracy differences. But once that sample size gets really, really big, the difference between the two is not really a thing. Okay, and so just some real life application there. Most of the time, the t-test is used. Okay, hope that helped.